Hello everyone. This PowerPoint goes up to page 20 in your books. This is the RK6 Blueprint Reading Module. This expands on your foundations. So we'll go into piping systems and the components you'll find into it. If you have the fill in the blanks, you can follow along. If you do not have the fill in the blanks, the summaries will cover all the need to know information. Let's get started. Page 3, Learning Task 1, if you're following along in your book. Pipe fittings and symbols. Piping systems have many components. The basics are type of pipe, flanges, fittings, and valves. On a drawing, there are two ways piping components are drawn. Single line, which is most common, and double line, which is used for larger pipe 12 inches and over. Piping systems move materials, usually liquid, from one location to another. Most commonly used materials are stainless, carbon, cast iron, copper, plastic, and Inconel. If you are not familiar with Inconel, it is an alloy of nickel containing chromium and iron, which is resistant to corrosion at high temperatures. Later on in the course, if we get some extra time, we'll let you guys play with some Inconel when we're TIG welding. On page 5, pipe specifications include nominal pipe size, wall thickness, and type of pipe. Nominal pipe size is inside diameter up to 12 inch, and over 12 inches it changes to outside diameter measurements. Wall thickness has three general categories: Sched 40, 80, and 160, which is also referred to as standard, extra strong, and double extra strong. Type of pipe specifies material. Carbon steel pipe is indicated as a grade A, B, or C. These indicate pressure specs. At the college, we use A106 grade B seamless pipe. The grades are based on carbon content in the material. Page 5 and 6 show pipe fittings. These change direction of flow, change the size of line, or connect valves and other components. You can look more into this on figure 4 in your book. Page 6, figure 5, take a look at the symbol for each connection method. In this picture, we have butt weld, socket, and threaded symbols. This diagram is missing flange connections, which are bolted with studs, not with bolts, unless you're at the pulp mill working on old equipment. Moving on to butt welded fittings. They are most common for 2 inch and above in industrial settings. Butt welded elbows can be long radius and short radius. Knowing the difference is very important for laying out. You wouldn't want to end up short on a piping spool. It doesn't look good on a job. So we'll get this hashed out. Here you can see the difference of long and short radius elbows and their turn radius. A short radius elbow has a turn radius the same size as its nominal diameter, and a long radius has a turn radius 1.5 times the nominal diameter. Nominal diameter refers to pipe diameter. An example of this is a 6-inch long radius elbow has a turn radius of 9 inches. So to figure that out, you take 6, you multiply by 1.5, it gives you 9 inches to measure for your turn radius. This is important for landing at the right spot when you're fabricating spools. Page 8, figure 9, moving along in your book. Miter cut elbows are further learned through parallel line development, which we will go through further detail later in this module. Reducing elbows change size of pipe. On a bill of materials, the larger diameter is mentioned first. Here we have some T-joints. There are 3 types. These are also referred to as a branch to a header. The straight T has all the same connection sizes. A reducing T has a smaller branch outlet. And a lateral has the branch outlet at 45 degrees, as you can see in these pictures. Page 9, here you can see 2 types of reducers. the concentric and eccentric. The concentric reducer maintains the same center line, and when placed horizontally can produce a pocket where liquid can remain stagnant. The eccentric reducer eliminates this pocket by keeping the bottom of the pipe on the same plane. The welding outlet, also known as weldolet, makes a right angle branch connection. This is the same as a T-joint, but this requires less welding. I'll post a video on your Moodle about fitting and welding a weldolet, and I will also get you to fabricate and do this in the shop as well. Knowing how to do these things can save you a lot of time in the field. Page 12 and 13 covers threaded, socket, and flange fittings. Threaded fittings are used on small diameter piping systems. Socket weld fittings are important for leak-proof joints. You guys have probably already done this with hydraulics. We will cover this in the shop as well to make sure you know everything about leaving expansion gaps and all that kind of stuff. Flanged fittings require studs that are torqued to certain specs. Always watch out for older flange connections because usually they contain asbestos as the gasket material. Here's your summary. Now is a good time to press pause. You can get all this stuff down. This covers all your need to know information. It's best to draw out the symbols because the symbols will be on your test. Moving on, learning task 2, valves and specifications. Here we have gate valves that fully turn off or shut off flow. They are not designed to do partial flow. And below is the globe valve, which can control flow and fully shut off supply. Page 18 and 19, check valves have a hinged disc that swings to prevent the reversal of flow. Safety relief valves are spring adjusted to release pressure at a preset limit. If a system gets overheated, you can burp off excess pressure easily with these type of valves. The symbols for these are below and above each other, just so you don't get confused with which symbol goes with which. Pressure reducing valves maintain a lower preset level of pressure. Control valves can be open or closed remotely. These are common so that operators are not exposed to dangerous conditions. They don't have to leave their operator's booth to shut off a system that's overheating or to burp things off. Valve connections include nominal pipe size, type, weight, pressure rating, and type of connection. Here's your last summary for this little section. There are no valves on the test, but it's good to know this stuff in case it shows up on your rid seal or in case you show up on a job and you need to put this stuff into service. Fun fact for everybody, never assume a valve will keep you safe, especially when you're in confined space in vessels. Always put a blind on the vessel side of things to keep you safe from material entering the vessel. We'll see you guys on the next slide.